negative feedback loops as it relates to geoscience. In this video, we're going to learn what negative feedback loops are and see a few examples. So let's start out with, what is a negative feedback loop? So a negative feedback loop is something or an output of a system that reduces its initial condition. So think of it as the end reduces the beginning. So if you're doing cause and effect, the additional cause leads to effect, and that effect leads to a smaller amount of cause. So there's the definition of negative feedback loops, but how does it actually affect your life? So you're actually alive because of negative feedback loops. It actually affects your body temperature, blood pressure, glucose production. They're all negative feedback loops in your body. Without them, we wouldn't be alive. But another reason is there's a reason the Earth looks like this and not like this, which is Venus over here. And that's due to negative feedback loops, because without negative feedback loops, Earth temperature would just keep rising continuously. So let's learn about a little local example we have here. So desert pavement, if you've been outside, you've seen it before. Desert pavement is caused by wind. So it's a negative feedback loop, and it's got to do with erosion. So the wind can move soil. Let's start with that. Wind erosion can move soil. So anytime you see a dust storm, that's wind erosion. Now, what happens is wind preferentially picks up smaller soil particles. It's easy for wind to pick them up. It's not very heavy. They just fly away. But if wind picks up smaller particles first and carries them away, you're going to be left with only larger rocks, as you saw in the previous picture. And once all the larger rocks are gone, the erosion slows down. The wind can't pick up any more soil because it's all gone. So that's an example of negative feedback loop. You can see at the end, it stops. You don't have as much wind erosion, or you'd have less wind erosion. Now, let's look at another example. One to do with Earth's temperature. So Earth's temperature increases. Let's say that's the initial condition. And let's say that most of the Earth is covered in water, which it is, and that water absorbs a lot of the sun's rays. Being 70% water, that's most of the Earth. Now, what happens if the water heats up? Well, if you've boiled a pot of water before, you know what happens when you heat up water. It evaporates. So if you have more evaporation, what do you think would happen next? So if you're in my class, go ahead, take a second, think about it. And as a class, go ahead and say, what do you think will happen next? Now. Did you get it? Well, if there were more evaporation, which would look like this, you would get more clouds, because clouds are just made of water vapor after all. So you can probably already see what the clouds might be doing. If the clouds are above the ocean, you can notice a cloud is a lot more reflective than water. It's a lighter color. It's got a lower albedo. Well, that means more of that light is going to be reflected back into space, and it's going to cool the Earth's surface. So Earth's surface cools and Earth's temperature increases. They're opposites. You can see negative feedback loop. This is not going to lead back to this. So let's do a quick check for understanding. Is this a positive or negative feedback loop? So take a second, decide, do you think it's going to be positive or negative now? Did you get it? This was actually a negative feedback loop, and it might be a little easier if I put arrows in to show that. So you can see more CO2 leads to existing plants consuming more CO2, but that means there's less CO2 in the atmosphere, and it wouldn't lead to more CO2, at least not by itself. You could add other things to cause that. So let's wrap this up. In summary, what are negative feedback loops? They happen when a process reduces what led to that process in the first place. And here's a few tips for recognizing whether you have a negative feedback loop or not. If it's on a diagram, if the arrows do not form a circle, that's a pretty good indication that's a negative feedback loop. Positive feedback loops will form a circle. Second, if you see smaller and smaller arrows on the diagram, that's usually an indication that things are being reduced, and that's negative. Lastly, if you see opposites, so two word texts that say the opposite things, you've probably got a negative feedback loop. Now, one key tip that I see a lot of issue, remember, it does not matter whether it's bad or good. It doesn't care. It's science, doesn't matter, just if it reduces. Anyway, that's negative feedback